It's showtime. Hello, guys. Hi. Welcome to Do It 3D Canada on Sunday night. I'm Tim. Oh, there's a lot of people here already, and thank you all for being here. Let's see who's here. We have Toaf here. Toph. Hopefully, it's nothing major. Mine is printing like a champ. It's this. This is the issue right here, in between these ears. I guarantee. HVAC A to Z Sergio is here. Non-fam. Hey, non-fam. Nice to see you in person yesterday on Jerry's stream. It's been a long time. It's about time. Very nice to see you. Nice to virtually meet you. And the guy, the Jedi, is here. Joseph Jolly. Jose Ferreira. Hey, Jose. Non-fam again. David Wilson. Hey, David. You may be peeping in here a little bit to help me out because I got things going pretty good. But this wire. Oh, there we go. I got a wire running up my chest. Yeah, I am wired, so you can check me for wires. Ready? Yeah. Let's see who else. Nick, and MGX20. Hello, and everybody who's here. 11 people watching so far. Very cool. Well, we've got, you might notice a little bit of a different camera setup. This little guy is going to follow me around where I go. This may end up being my discussion, my talking camera. And it's also a good way for me to show you around the studio when I'm over this way, showing you what's where. So just trying something different. So we will see. Frisk you. Let's go. Frisk me for a wire. And if you do, you will find that I do have a wire on me. Just gonna scoot it down my shirt. I am wired for sound, yes. So, but I've never been undercover officially. So that doesn't mean anything though, does it? Oh, I lost one viewer from talking about frisking. So let's stop all this frisk talk, shall we? Okie dokie. 10 people. Okay, well, I suppose we can start. I don't get huge audiences on here anyway, so no big deal. So good news is that, oh, very nice camera. Thank you. This is called an Insta360 Link camera, this one here that follows me. Okay, it's a good camera. It's got pretty good quality. The other camera that I have, of course, is the regular, the Sony A5100 camera, which is right there. It doesn't follow me, but it gives more of an overall kind of look. We've got this one hooked up, and then, of course, we've got this camera hooked up overlooking the RatRig way above me over here. So, yeah, hopefully we can get things going. Yeah, make it print. We will make it print. Yeah, nice to virtually meet you too, non-fam. It was great to see you. And don't you worry about, you were concerned about your English. Your English is fine. It's perfectly fine. Better than mine, as a matter of fact. So, I printed a test piece yesterday on the RatRig. It looks like crap because I haven't done any, haven't configured anything. I think the belts need a little bit of tightening. The only thing that looks good on this test piece is the... To be totally honest with you, the only thing that looks good on this test piece is the first layer. Okay. If we look at the outside, it's terrible. If we look at the top side could be better. It's not the best print in the world. This is totally uncalibrated, but the fact is it printed. Okay. And the exciting news is that because we got a really, really nice first layer on that from that textured bed, that tells me that the beacon probe did its job, what it was supposed to do. The issue we had was, and this is where my knowledge is like, here's 0, here's full knowledge, here's 0. My knowledge for macros and how to fix them it's probably down around here somewhere like that. Maybe up here because I could probably stumble my way through it, but definitely not above this line. So I think there's something going on with the startup macro, because I do have, as my good friend David Wilson in here suggested, in the G code, when I slice the file, my starting G code is just print start. My ending G code is print end. Okay, the macros within Mainsail take care of everything else. Okay, and they did. They took care of everything else except something going on where it's either not reading the right size bed or it's not doing something, because it worked, it scanned and everything, but it came up to one corner and it kind of went, but then it kept going. Then when I went to purge the filament, prior to the print starting, it stuck right onto the bed. Nothing happened, and filament just went to the point where it was actually pushing the bed down because there was so much pressure from the filament. Then it finished, stopped, and went ahead and started printing. So the purge line didn't move, obviously, and so there's a few little things that need to be tweaked. In the macro, and I don't know why, I don't know where, I don't know how, but we're gonna figure it out. But the exciting news is we did get filament pushed through this thing. Yeah, I didn't do it on my live stream because I didn't want to waste too much time on it. So default is a blob. Default is a blob, is it really? Oh, well, I didn't know that. The load macro G code works good. The unload macro filament G code works good. The unload filament and load filaments work good. The only thing about the load filament G code I would like to do is I would like to have it so that it lowers the bed a little bit for me. And if it is a blob, Toph, adaptive purge is awesome. Highly recommend that macro. Okay, but if the default is a blob, Toph, that's fine, but I'd like the bed to be lowered a little bit so the blob doesn't the nozzle's not here and the blob just moves, because then that causes it to wrap around the nozzle a little bit. So, but we can probably change that if I knew how to program a macro. Because you go into the macros and it doesn't give you an option to save anything you might change in the macro. That's where I need the help of you guys. Yes. It makes Dingleberry. It does. It made like a little poop pile. Exactly what it made. I don't even know if I kept it or did I toss it, but it made a little bit of a poop pile. Yeah. Anyways, let's go ahead and see if we can figure that out. So let's go ahead and look on. Do I have, if I switch to the display here, ooh, and I'm even in the bottom corner of the display, so that's okay, she can still see me. So there's my display. There's what I'm watching on StreamYard. Boom, 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 boom. Okay. If we go to the OS, which is right here, the printer's running. And that's the other thing. The other thing I want to try and figure out why right now the part cooling fan is on at 100%. Just the part cooling fan stays on, period. I'm sure there's a way that I can have the part cooling fan not come on until I need the part cooling fan to come on. In the initial wiring of the part cooling fan, it showed 3 wires going into the board. My part cooling fan only has the 2 wires, the plus and the minus. It had a 3rd wire on the fan it used. The fans I have only have 2. So that could be something to do with why the part cooling fan is, I keep wanting to say fart cooling fan, why the part cooling fan is constantly on. So maybe we can figure that out too, possibly, right? Let's go back to display. So under, that's the part I just printed recently. Everything is working fine. We did a PID tuning on the bed and the hot end last week. David Wilson says, Tim, did you put your hand up, David? Oh, I think that's you putting your hand up. Yes, David. You're going to say, oh, Tim, that's in the config file I sent you. You just sent me an email with the stock. Okay, let me have a look and see. Let me check my emails with stock. I used the stock setup, and I got a couple things from your setup, Dave, and everything seems to be working fine except those few minor items. Okay, let me just see if I got an email. I got an email from you. Printer config macros. Look at that. Print a prime line or blob at the end of the start print macro, hashtag to set the prime line or prime blob, or false to disable nozzle priming, variable nozzle priming, prime blob. Hey, Teza. Well, Toph, that's easier said than done for me, but hey, let me look at what David sent me. Use absolute extrusion mode. So this is the macro that you're using, David, and it's working fine. Now, I guess my question is, G-code mat macro OS, start print macro, calibrate the bed mesh and start print. Okay, now where am I putting this? That's from the printer config. Okay. Okay, so I got, let's see if I can show this screen and hide. There's nothing on here that is, private in the printer config, and do I put it at the very bottom? So this is what you've sent me. So you sent me this G-code macro configuration. So I guess I highlight this whole thing and put it in the printer config. That's at the very bottom, isn't it? Below those lines where it says to not edit anything down here. Dude, hey, Rob Cooper, how are you, sir? How are you, Rob? I haven't seen you in a long time on here. So happy you popped in. Hey, we were talking 3D printing and macros and G-code and all sorts of funky stuff here tonight now. Yeah. So, okay, so we have the display just above the don't edit. Okay, so let's go ahead and take this portion here. Let's just take all this. We'll copy this sucker. Okay, we'll minimize this window. And then you're saying, let me just make sure. David Will says in the printer config file. So we're going to go to machine. We're going to go to printer config, which I think is up one level here. Printer config, and just above where it says don't edit. So we got to go down to the bottom here. And then down here is where it says toolboard, if you have a toolboard, blah, blah, blah. BL Touch Probe. Oh, right here. Do not edit this block or below. So you're saying to put it just above, just in here, David, is what you're saying? Yeah, a lot of comments on things I can change, but I want to keep it simple for now. And the problem, if I read every comment and make all the changes, I'm likely going to make an error. So put it right in there. So let's add a line. And this is the type of stuff I learn as I do more. Paste all that in there. There we go. And let's get rid of that one blank line there. Okay, variable macro print in front. So that's all I need to add in there is what you're saying, David. And variable calibrate bed mesh true, variable nozzle priming prime line, variable start print in the back, yeah. And variable start print park Z height 50, perfect. Yeah. And then variable park in front, back, yes. Variable pause and print and park front. Okay, this makes more sense, especially that part about the Z height 50 for the startup. Hey, Will, good day. That is why you don't like RatRig OS. They tried to organize too much that they made it too complex. Well, you know, it's different. Let's save and close. Let's save and restart on that one. But I will say, Will, yes, it's a lot different than finding and figuring out the macros in here than it is in the these guys over here for the Vorons. So, but I think what RatOS did is they tried to make it a lot simpler, so that you didn't have to know or think or do so much. So it has too much flexibility. Yeah. Anyways, well, we'll try that. So we're restarted here just fine. Let's go back to the dashboard. Let's go ahead and just make sure everything's working okay. So let's get the camera here over to the floor camera. This is all built. Let's just do a home all just to make sure everything's running. I may have to tighten my belts a little bit too. So I'm not going to worry about that right at the moment, but I got a little bit of wobbly gobbly stuff going on this thing that kind of tells me that my belts might be a little bit loose. What you using to switch camera views? Rob, I'm using something called a Stream Deck. I have a couple pieces of equipment here. I have my HDMI cameras are plugged into an ATEM Mini Pro, and I am using a Stream Deck, 15-button Stream Deck to switch my cameras. And they're in conjunction with my ATEM Mini Pro. The ATEM Mini Pro is great if you have all HDMI cameras. A few of my cameras, including the one we're looking at here in the top right corner, are USB. My main camera over here is an HDMI camera, which is plugged into my ATEM, yada, yada, yada. Oh, I like it. Yeah, I love I love everything, my entire setup. The main thing right now for my ATEM Mini Pro is my audio. I don't have to worry about a soundboard or nothing. This audio is coming right out of the ATEM Mini Pro through my Rode wireless go-to microphones. But the Stream Deck for switching screens, like, you know, I can go from my display to my floor camera to my main camera to my bench camera, which is at the moment not aiming on anything other than, oh, it's right over here. Hang on, there's my bench camera. Whoop. There we go. But but I can switch between all those things with ease. But yeah, if you don't have a Stream Deck and you're streaming, you need to get a Stream Deck for sure. Okay, so we went ahead, we homed no problem. Let's go ahead and print the same file I did yesterday just for fun. Actually, I got to load Filament first. And what I need to do here, would like to do a deep dive on the beacon probe. You're not sure anyone has done one for the RatRig. Oh, okay, cool. Hey, no problem, Rob. Anytime. You know how to get a hold of me too. So if you ever have any questions that I don't answer and I'm not on stream, you definitely know how to get a hold of me. I've decided what I'm going to do with the RatRig too. Here, I'll show you. It's easier if I show you on this camera here, because I'm going to come up here right now. The camera should follow me right up. So I have right up here, you can see some spools that are just hanging above me here. They've been up here for a long time, and these are just old partial spools of filament. So we're going to pull these down. And I decided I'm going to rig up something similar to this over above where the RatRig is going to finally live. And we're just going to feed filament from the ceiling into the RatRig, because that way I can put on 1 kilogram spools. I can put a 5 kilogram spool on there if I wanted to. So because this rig up is pretty strong, I'm just going to go ahead and get rid of all these, and I'm going to put some fresh filament on, because the filament I printed with yesterday could have been part of the issue, because this stuff's been sitting up here for probably 3 years, probably needs a little bit of drying, and these were just all old test spools and stuff. So let's just put these spools aside. The camera doesn't like when I go out of its range. It's like I'm insulting it or something. Okay, we're going to put these spools aside, and we're going to see. We'll just throw some PL. See, the camera didn't like that. I went out of its. Oh, there we go. Went out of its focus. He doesn't like when I do that. That's the one thing about this camera. All right, you got to get back with me. So let's find some. Let's use some Jesse PL. Not Jesse. Let's use some Polylite PLA. And let's pick. Do I have anything open here that's going to stand out? Let's try. I don't know what color. What color should I pick? Drive down one day to talk. Absolutely, for sure. That would be nice, Rob. Definitely. Let's go with. Let's just put a red on there. Let's go with Polylite red. And again, this thing doesn't like when you turn your back to it. You got to kind of unhook that and click that again, and then it'll start following again. Okay, so let's throw a spool of red on here. Blue, nah, red will stand out better. Oh, look, it's a brand new roll. That way we're not gonna, don't forget to invite me. I will not forget. Oh yeah, Will. Yes, don't forget to invite Will. Where's my scissors? Polymaker, my filament of choice. I love Polymaker filament. So opening a brand new spool is gonna say to myself, I'm gonna say, any issues we have, not gonna be filament related. Well, I say that, but you never know, right? We should all go to Tim's for a party. Yeah, there we go. Now, where is the end? Ah, there is the end. And come on, the tip of it broke. I broke the tip. There we go. I want to make sure that's not. That looked like it was tangled in underneath that second layer there. I think we're good. Okay. So let me just cut this end clean. Okay. And let's go up and throw this up here. We'll just throw a single roll up here for now. You'll fly from Kansas, David? Absolutely. You are welcome anytime. Okay, so we're going to come down. Whoa. Put this right above. I put a little bit of PTFE tube in here. We'll just shove this in. Shove it in. Come on. There we go. And I'm just going to wind in just a hair so it stays connected in there. I don't know how well this is going to work. I may have to come up with a little different solution over there, but this will work for now. There you go. Now, what I like about this tape to keep the poles, I'll just come up with a little better design. I might even come up with some bearings on the end so it rolls smoothly as well. But bearings where I can actually snug a little break up. Too long of a rod. It is, exactly. Well, I will have a short, this was just a storage thing. I'll definitely do something shorter that'll accommodate a 3 and 5 kilogram spool, but that's it. And it'll be right above it. And I'll have some sort of a guide or something like that. But I also want to make it with some bearings so it rolls smoothly, but also have some little brakes, so like bearing brakes, so it doesn't roll like, right? So like, you like that sound effect? Anyways, so another nice thing about this is they have a nice macro down here, right there, that says load filament. So I click that, and it's going to preheat my hot end to 220, and it's going to automatically load my filament. And when I load the filament, I like to have, we'll go back to this guy, I like to have a little bit of a gap. Let me move this camera over just a hair. There we go. I like to have a little bit of a gap between the nozzle and the bed so that the filament has a chance to flow freely without gumming up all around the nozzle. So is that in focus? That's not bad. And I have a portable light here that I can put on because it's not the best lighting up there. So I have this another one of these really cool tools. This is called a HSI refer. It's a video light. It's a rechargeable little video light that's extremely bright. Lets you change the color range on it, the color temperature, and the battery lasts a long time, 3 or 4 hours. So there we go. Floor camera. We are extruding filament now, so it is loading. I don't know if you can kind of see the filament popping out there. Let's get this light up here. And on. There we go. Yeah, you can kind of see filament coming out now. So it extrudes, I think, about 100 millimeters of filament, just to make sure we get the right color in there, and we are done. So let's go up here and clean the filament out of here. There we go. So we extruded about 100 millimeters, maybe 50. And if you want to do more, I'll do it again. I'll purge a little bit more because I had a darker color in there. We'll just go load filament again, and it's going to purge out some more. I love that little wheel. 100 fast and about 20 slow. There we go. And I haven't done I haven't done an EStep calibration on this yet either. So will not provide Cuban sticks for any. That's okay. I don't need any Cuban sticks. I'm good. Okay, so we're definitely purged to the right color now. And we'll get that. We'll just do that same print. I'll slice that same print up. There we go. Okie doke. So we have our filament. So we are using a Rapido hot end for those that need to know. Rapido high flow hot end. I got a little bit of filament stuck somewhere here. There we go. Got it all off. Got it all off. Okay. Oh, thanks, Rob. Appreciate that. I'm trying. That's one thing I always struggle with is cameras and what angle to do things at. So cool thing here too, guys. So we're going to minimize this. There's my main screen. That I was using Prusa Slicer yesterday too, but you know, watch this. Orca Slicer. Boom. So there's the RatRig here. Let me make this full screen to make it easier to see. There's a RatRig and Orca Slicer. It comes as a predefined printer in Orca Slicer, the RatRig 500, and then when you go to the device, look at that window. Look familiar? Right under device, you have your RatOS window right there under device. It's perfect. So anyways, there's our prepare screen. Let's go ahead and find that. I may as well just run that same file really quick because I know it's here. I think it was fuel pump. Is it this one here I did? Why aren't you coming in? Come on. Oh, it's a Windows thing. There we are. That's not the same file, but that's okay. Let's automatically put that down. Now, this is where I need to get rid of some filaments because I've only got one, and we're going to call this generic PLA. because everything will work fine on this thing. We'll just center it on the bed. We're going to do 2 skirt loops. Skirt distance, since we have a 500 millimeter bed, we're going to do a 75 millimeter skirt loop. What? Maximum is 10? I like a bigger one, 25. Okay, it looks like they're only going to let me do a 10 millimeter skirt distance. Huh. Then I'm doing 3. I do the skirt. I do like doing a big skirt when I can, because it lets me adjust the Z offset if I have to. I didn't have to in this case, so let's just go with this. I don't want to do a brim. No brim. Okay, quality is 2.0. We have a 0.4 nozzle. We're fine. We're going to do 3 walls. That's fine. 4 top, 4 bottom. That's fine. 15% infill. Fine. This is just a test print. You can't get used with Orca Slicer interface just yet. I've been using the Orca Slicer, of course, with the bamboos. So with the bamboo printers, the P1P, and now my P1 converted P1S. 15% infill is fine for what we're doing here. Speed, we're just going to leave it at the standard speeds. We don't need any support. So let's go ahead and slice this up. Okay, looks like it's going to be 1 hour, 48 minutes. We don't necessarily want the whole thing to print. We're just going to, it's mostly a test right now. And then if we go ahead and, is this going to let me print it right to the device? It is, because it knows my code. So if I go print, so I'm just going to upload for now. You can upload and print or upload. I'm just going to upload, make sure it comes over, come back over to the device. There's the print right there. So we can go like this and print the job. Our bed's going to heat up to 60. Our nozzle's already heated up, although that's going to cool down to 150 to do its probing. So once that all heats up, I'm going to switch over to the camera. Hey, Rex Waldy, and you guys can see how incredibly fast this excuse me. That was pretty rude of me. How incredibly fast the beacon probe is on this thing. If you have a 500 millimeter bed, and the bed allows you to, because a beacon only will not work on some kinds of beds, but get a beacon probe. Oh my goodness. I mean, it's incredible. Where's my beacon probe box? I don't know where I put it. It's around somewhere, but yeah, get a beacon probe if you have a big bed. Even on a small bed. Okay, our bed's at 49. We've got a little bit of nozzle leakage happening here. Usually only happens in nozzles that are 60 like me. Sorry, that's bad. Let's just, there we go. Okay. Then we'll see if that code works, David. See if you're my hero. You know, I can take the time and learn how to edit how to edit macros and all that stuff, but man, it's complicated. I think if you do it every day, it's good. That's why I like this community. Somebody else has done it. So would the beacon work on a glass bed? I don't know. The beacon works by I'm not even sure how the what the probe type it is. Looks like it's a car humidor behind me, but it's not appreciably. No, it's a these are 2 3D printers behind me. This is the one that I just upgraded to the P1S, and then this one here is the Creality K1. Yeah. Okay, we're cooling down. So as I thought, we're cooling the hot end down to 150 to do the probing. The bed is already heated up. The bed heats up very fast, of course, because it is an AC bed, right? So yeah. So once that gets down to 150, we're going to start our probing off. So let's go ahead and switch you guys to this camera so you can watch. And we'll also watch and see if this macro does what it's supposed to do. Let's get this light back out of the way a little bit. Whoops. There we go. IPA again. IPA. Isopropyl alcohol. No, I don't need to, we should be good. If that's what you mean, Steve. Got to go. Vacations are over. Tomorrow's work day and got to get up early. Cheers. Hey, K. Jose, thank you so much for being here. I appreciate it. Okay, here we go. So what we're doing right now is doing a Z-tilt adjustment. And the Z-tilt is it probes the bed in 3 spots. And all it does is this levels out the 3 Z motors to make sure that the bed is basically perfectly level based on the 3Z motors that the bed is being leveled to. Usually goes around twice. And it usually gives me a very, very good tolerance. So the tolerance on this is 0.02 millimeters, which is 2/100ths of a millimeter. So, and right now it is at 0.01. Now we're homing on Z, and now we're going to go ahead and we're going to do a mesh. Watch how fast this does its mesh. And yeah, it's working, David. I had issues before, and this is working fine. But this is doing a complete bed mesh twice over. Watch how fast this is. Okay. And the last one. Now it's going to do its second time coming back. Can you imagine if I had a BL touch on this thing? I'd still be on the third or second probe spot. This is about 30 seconds to do this mesh. Look at this. Hey, Michael Henke, how are you? Hope I said that right. There we go. Mesh is done. Okay, now we're lowering the bed. Now we're heating the nozzle. David, you're brilliant. Thank you. It worked. Thank you. That solved all the issues that I was having with the other macro, so thank you. Let's go back to that. We don't want to see my face, even though I'm happy. Okay, let's see what happens once we get warmed up here. I'm going to be ready on the Z offset adjust, just in case. Shouldn't have to adjust anything, but we will see. Eddy currents, that's what it is. Thank you, Teza. Eddy currents. We'd still be probing with a BL touch. Okay, here we go. Coming up to start the print. Okay. And there's our purge line. Purge line. We look like we're a little close to the bed. Oh, maybe not. Yeah, we're a little close to the bed. Oh, maybe we're not. I had some gunk. You know what it is? My sock is too low. My sock is too low. No, I don't think we're too close to the bed. My sock is slipped. Yeah. The nozzle sock has slipped a little bit down. That's what's causing it to rub on the filament. Let's see if I can pop that sock up while it's doing its thing. No, I'll do that when it's cooled off. But there we go. We have a print. Let's see how this first layer is going to look. Let me zoom you guys in a little bit here. And sorry, it's going to get out of focus while I zoom. There we go. And it's probably still out of focus because you know my eyes. There we go. I need better elastic on my sock. I do. There we go. That first layer is looking really good. We've got a little bit of a blob right here and here, but the sock is too low, and I think it was dragging on my filament yesterday, and a lot of this is residue from it. So I got to pull my sock up here. It's a little bit low. I could adjust that a little bit there. Now mind you, I have not calibrated a thing on this. Let me move my Z to -0.05. We'll adjust that a little bit. Oh yeah, that sock is dragging. Oh. Okay, let's stop this print. I think as it gets hotter, it's just going to continue dragging. Okay, there we go. Okay, let's go ahead and home this. And then I'm going to fix that sock. Here we go. Let that cool off a little bit. Then we'll fix the sock. She said that too. That's what she said, yes. Okay. Yeah, because it was hitting the first layer there. Let me just pop off. Yeah, we're not too close. Well, we could be a little bit further, but it's not bad. Yeah, we're a little bit tight on that first layer. But that droopy sock is definitely not helping things. Okay. And the other thing that's happening is my stupid part cooling fan is still on full time, even on the first layer. And I don't like part cooling fan on the first 2 layers. So we got to figure out why. But let's see if I can pull this sock up. There we go. That's better. Okay, that's much better. So you'll see now, bench camera. You can kind of see now that we can actually see the nozzle. I couldn't see the nozzle before. The sock was so low. So, yeah. What a pain. So, I think that's okay now. So let's try that once more. Well, we got to do an EStep calibration too. Can you turn the fan off from main sail screen? See, okay, let me check. Right now, let's just make sure I'm not lying. Yeah, right now the part cooling fan is going at 100%. If I go to the main sail screen, and where's my fans? Okay, so right here we have our controller fan. They're staying on at 100% no matter what. So our tool head cooling fan is on regardless right now because it'll turn off when the temperature hits 50 degrees or lower. The sock was so low. It was so low, Teza. So once that hits 50, that'll turn off. And that is the tool head fan, or the controller fan is in underneath. My part cooling fan says 0, but it's on regardless. And it even sends the right code, M106S0. And it's staying on. As I said, when it showed the controller hookups to the board, it had a 3rd wire, which I think controlled the on-off of the fan, which I didn't have because I've only got 2 wires on the fan. The pins might be wrong or wired wrong. That's what I'll have to look into. Although, let me double check. Actually, I assume they were on while it was printing the first layer, but I didn't actually go up and physically look. I could have been hearing the hot end fan instead of the part cooling fan. Okay, well, but let's try and run that again. And I'm going to lower the Z a little bit as I'm going to raise the Z a little bit when I do the first layer here. 3-wire fans are usually PWM fans. Yeah, and that's, I think, what they had given me instructions for, was the PWM in the board pinout for the assembly. But of course, I didn't have that fan. So, and I think I don't recall if it used to be that one or not. But that's probably not a hard fix to fix. The fans are 2-wire PWM. 3-wire fans are usually PWM. See, that I don't know. I don't know. All I know is I could, let's see if I have that diagram, if I can pull it up. I believe it was configuration. No, I'm trying to find where it was. No, this is the configuration. It was more so in the assembly. And I'm trying to think. It was No, I don't know where it was. It was in the assembly instructions. I'll have to look at that in a bit. But that's okay. That's a minor issue, as I say. You can still get a print cooling the first 2 layers. It doesn't matter, as long as you get decent adhesion. So I'm going to go ahead and start this print again. Let's go ahead and wipe it first. They're normal DC fans. Okay. What's PWM? Print with memory? No, I have no idea. No idea what PWM is. So let's start this print once more now that I fixed the sock. And I'm also going to adjust the Z offset a little bit more. And then once I adjust the Z offset, if I have it right, we'll hit save and it'll update it in my config file as far as giving me the right Z offset. But I think I need to raise it up a little bit, which is basically a little bit of a plus here to raise the Z a little bit. Pulse with modulation. Pulse width modulation. Okay. Never knew that. Okay, so we're heating our bed again. Pulse width modulation. You guys all know this stuff. I don't. It's all this technical crap that I have no clue what I'm doing. Longer the pulse, the faster the fan goes. Oh, I get it. But I'm pretty sure all my other park cooling fans on the Vorons, etc., are 2-pin, and they work fine. But maybe I'm mistaken. Maybe they are 3. No, I don't know. I just don't know enough. But hey, that's just more homework for me to do and more things for me to figure out. There we go. Here we go. Let's go back to the floor camera here. Watch it do its thing again. So we're doing our Z. We're doing our Z tilt adjustment again here. That was fast. Only went around once. And now we're going to do our bed mesh calibration. So really starting a print using a beacon probe is extremely fast compared to when I was starting a print using a BL Touch in the previous build of this thing. Instead of steady on, it tickles. It tickles it. It tickles it. Oh, man. You said tickles. That's funny. The duty cycle of the signal. You guys are all talking technical stuff to me now. Come on, just tell me it's on and off and slow or fast. Okay, let's get ready to raise our Z a little bit. I think 0.025 is about in order. As a matter of fact, I can do that now and it'll do it when it starts. I asked. Yes, I did, Jack, didn't I? Okay, let's get up here to this guy. Third wire would be more for a tachometer, not needed for a simple cooling fan. Yeah, and they had it. They had it on the RatRig thing and blah blah blah. But yeah, that's why I didn't even think twice about it. Let me just get this snot off of here. Who's calling me during my stream? Not going to happen. There we go. Oh, I think it might work better. Oh, look at that. It works so much better without a sock on it. Okay. Yeah, that is looking a whole lot better. It's probably still a bit low. Let me raise it up a bit more. I'm always confused. Do I want a plus or a minus if I want to raise it? I want a plus. There we go. And yeah, that feels good. Maybe that's a bit bright. No. Let's see how this goes down. I think I might still be a little close to the bed. Yeah, I have a feeling I'm a little close to the bed yet. I think I'm going the wrong way. Yeah, I think I'm going the wrong way. Oh, I'm very happy with the start now. No, that wasn't a landline. Am I going the wrong way? No, no. Hang on. Oh, let me get up here and look. Yeah, I have 100%. That the cooling is killing my first layer, but we'll still let it go anyways. Yeah, where it's cool, it's doing 100% cooling fan right now. Or is it? Hang on. Yes, it is. Both fans are going. And I don't like a cooling on my first layer. It doesn't help it. So I'll have to figure that problem out. Let's let it get beyond this first layer and see anyways. Oh, yeah, I haven't adjusted my E-steps yet, Toph, so that could be the issue as well. You're right. That could very well be the issue. I haven't adjusted E-steps. I haven't adjusted, I haven't done any tuning. So we'll see. And I still have some blobs coming out from the old filament. So I've obviously, that sock, was when it was too low, was dragging filament throughout the whole hot end. Something terrible. But you can see it's a terrible first layer. I mean, it's awful. It's almost like embarrassingly bad. Yeah, we definitely have to make some adjustments. I just want to see how fast it goes after the first layer. What's my retraction? I'm not sure. I just sliced and printed. Man, that big blob on there. I got a little bit of a, there we go. Oh yeah, I got a lot of garbage all over that sock from when it was dragging. It's going to take a bit to clean it up. Okay, thanks, Rob. Appreciate you dropping in. Yeah, definitely connect. Yeah, I think we're still too close to Dave. I really do. Let's see. Maybe I'm going the opposite way when I, oh no, there we go. Hang on. Ah, there we go. I just gave it a major bump up and it looks a whole lot better. Oh yeah. Okay, let's try that. Let's start that again. I know, but we're going to start that again. I'm going to let it go for a few layers and then we're going to start again with this new Z offset. Here we go. Oh, second layer will fix anything. But I like to have a good first layer. Let's see how this goes. And it's shaking a lot because it's still on a Lazy Susan. I haven't done the input shaping at all yet. Oh yeah, second layer looks so much better. What I want to do is I want to do a model, and my belts are way too loose. Holy crap, my belts are loose. I should not be able to wobble my belts like this. Oh, they're loose. You can see. Yeah. Oh, if I wiggle my belts, it kills my layer. Look at that. Watch, watch. Wiggle my belts, kill my layer. But the belts are too loose. We've got to snug our belts up. Yeah. You can see, I don't know if you can see too well on camera, but yeah. So we're going to snug the belts up a little bit. Yeah, I did that on purpose, actually. Yeah. So if I, yeah, look at that. Yeah. Okay. Oh, we're pushing plastic. Um, we know that. So let's go ahead and stop this. There we go. Yeah. And let's zoom this out again. Doop, doop. There we go. The whole rig is moving. It's the whole rig moving. Yeah, the bed is solid. Let's just get up here and pop this off. There we go. Yeah, I'm too close, and you can see. Now some of it's exaggerated because of what I did. Come here. Don't be shy. But I wiggled the belts a little bit, but you can kind of see even before I wiggle the belts that the belts are too loose for sure. So yeah, definitely an issue with the belts. So let's go ahead and make a couple adjustments here. Let me throw these plastics out. I'm going to pull this light down. Oh, that's bright. I'm going to let's bring my belts forward. So let's go ahead and home this so I can move my axes towards me. And we're going to snug up the belts. Make a couple adjustments here. Yeah, the whole rig is moving. Like right there, the Lazy Susan, you can see it right there. It's got a permanent home over there, and once I get it on the permanent home, it won't move. Oh, and what I've done, don't know if I showed you guys. I don't. As far as my drag chain and everything goes up here or whatever. That's how we took care of. So we have an arm coming up from the back. We enclosed all the wiring, and we have one of those key backs hanging on it. So we have a key back hanging on it, so that it helps keep that all up and out of the way. So that works out quite well. Sorry for the bad lighting on that, but that is that. Yeah. Thought you were having a stroke. No. No, you're all good. Okay, so I need, so where we got to snug the belts up is on both sides. There's little bolts. There's a bolt right here and a bolt on the other side, and that's going to pull the belts snug. You put one foot down from your bed. Having a little bit of vertigo, were you? I had a bit of vertigo earlier this week, and oh, it was not fun. Okay, I believe it's my orange key I need for this. That's too big. Not Mr. Orange, it's Mr. Yellow. It calls it mellow yellow. Just adjust it. So we're going to give this a few turns, because they are pretty loose. There we go. So we're going to turn this now. Whoops. What am I hitting? Oh, the wire. Power cord. There we go. Now we're going to give this one a couple turns. That's better. That's better. Yeah, these belts were definitely too loose. And there's a lot of room for adjustment in this, so that's much better. Oh yeah. I don't have a beltometer or a dingle bobber or a thingamadoober that, you know, measures belt tension, or a guitar tuner where I go twing, 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 twing. Anyway, so that's a little better. Come on, don't be shy, camera. I think I insulted my little camera. It doesn't want to follow me anymore. That's okay. Okay, so we got the belt done. Tension to the belt. Now I should do my EStep calibration. Now I know it's not the same with ESteps. It's rotations or something with this, isn't it? So let me look up that and see what I got to do with this. So I believe we should just follow the balance of the tuning guide is what we should do, but under configuration using Excel, so we don't have the ADXL hooked up yet. That's one thing we do have to do. So we've done the Z offset. Okay. There's a button in RatOS to measure tension. You want the peaks to be exactly centered. Huh. There's a button in RatOS to measure tension. I didn't know there was. Huh. We'll look at that. We've done all these other things to begin with. Install configuration, verify stepper directions, which are all going the right way. Verify end stop Z probe, Z offset we've done. Oh, one thing I do need to do is go back into RatOS because I stopped it, and I need to go down to my Z offset and save it. Need to save my Z offset, and it's just going to restart it. That's going to adjust the Z offset for future prints going forward, so I don't have to go ahead and do that manual configuration. Okay. Now we don't have my accelerometer hooked up yet. Installation slicer configuration. I'm looking for EStep calibration, which I think is called something different. Generate shape or graph. This is all to do with the ADXL. There's our macros. I got to read through this whole section. Configuring RatOS macros. You see, there's a good way for me to learn macros is read all this, right? But right now I want to do my EStep calibrations. Adaptive meshing. Adaptive meshing is going to be interesting to look into too. There's a lot of stuff to learn here. But let's just see if it talks about my extruder calibration here. It's a little bit different than the instructions for Clipper. Connecting a 4028 fan. Oh, maybe. Okay, hang on a minute here. Oh, a 4028 fan is a 4-pin fan. That's what I'm not doing. Yeah, see, this is what they said to do. A PWM pin and 2 here, but I'm not using a fan like this, right? So but they don't tell you how to do it otherwise. I guess if I do a lot of reading, possibly. Oh, and there's the 4th pin right there on a 4-pin fan. Anyways, okay. That just caught my eye. It was like a squirrel moment. It just caught my eye for a minute there. So what I need to do is I need to go to the Clipper documentation and look for hey, Joe Galaska, sorry, Galaska. I've got to look at my Clipper documentation and find my ESteps, which I think is going to be which is rotation distances for ESteps. There we go. Rotation distance, full steps for rotation, blah, blah, blah. It's been a while since I've done this on a Clipper. Okay. I'm just doing some reading. You guys can read along, chat away, etc., while I do this. Okie doke. Why did I switch to that screen? Where was I? Right here. Positive of the fan to the signal and the ground to the ground. That's what gives you the PWM on a DC fan. Positive to the signal and ground to the ground. Oh, so if we go back for a second on this diagram, so are you saying in this, Teza, are you saying on this diagram here, okay, the red is the positive, are you saying that this, and is the PWM not the signal? See, it's got the ground going here. Yeah, that's sort of where I get confused right here, right? See, and they have a, on a 4-pin, they have the black going there. I'll have to look further into that. So it turns the fan on with the pulses of the signal. That makes sense. Versus the way I have it right now, which is right here, it's always on because it's getting a constant 5 volts. There's nothing signaling the fan to turn on and off. So I need that red wire to go to a different port, obviously, which is going to signal to turn it on and turn it off. I just need to figure out where that port is going to go, which one, right? I need to figure out which plug, that red plug, which port that red plug is going to go into. Now, I don't think it's going to be where the blue one's going in, because that's just a negative plug on another negative port on another plug, because these are all negative pins and these are all positive pins. So, yeah. Okay, let's get back to this for now, and I'm going to keep watching chat. The blue wire is in. So you're saying, and I know we're going back and forth, so you're saying that I should be putting the red pin over to where the blue wire is. Is this a signaling? Interesting. Well, let's look into that in a minute. Let's look into that, because the blue wire on this is obviously the signal. So I'm assuming then that what's going to happen is it's going to be the power and the signal. Calibrating rotation distance on extruders. Yes. Okay. I'll have to try that, Teza. Definitely. Make sure the extruder has filament in it. It does. The hot end is heated to an appropriate temperature. I will. Use a marker to place a mark on the filament. I will. Then take the extruder of the body, then use digital calipers to measure the actual distance of that mark precisely as you can. Initial mark distance. Extrude 50 milliliters of filament with the following command sequence. Note 50 millimeters, requested extrude distance, wait for the extruder to finish, move it, it'll take about 50 seconds. It's important to use a slow extrusion rate for this test, as a faster rate can cause high pressure in the extruder, which will skew the results. Agreed. Do not use the extruder button on the graphical front ends for tests, as they extrude at a fast rate. There we go. Okay, so let's go ahead and mark it. I always do 100. Okay. I'll mark it at 50 and 100, but I always do 100. And then we're going to use the command G91 followed by G1E50, but I can do G1E100 and F60. Okay, Teza, we'll try that. That's okay for now. We don't need that for this. Let's get this done here first. So I'm going to use my blue one, and I need a Sharpie marker here. I'm going to try and get my extruder calibrated here real quick. And where's my Sharpie? Purple Sharpie on red filament should work. So we're going to come up here. I know the light's going to be bright here. Forgive me. There we go. So I use my I have a homemade extrusion tool here for measuring this. So I have this thing here has notches in it every 10 millimeters. And I have a big notch at 100, big notch at 120. So I'm going to go from the top of this PTFE tube. We just place the filament in the slot on this. Okay, the camera's not high enough to see this. There we are. Place the filament in the slot. Grab our Sharpie, and we mark the filament at the 100 mark. And then I can mark it at the 120 mark. I don't know where my black Sharpies went to. Hopefully I can see the purple on there. Let's see. Yeah, I can see the filament marks on there for sure. Okay. Okie doke. Man, that light is bright on this. If I turn the camera, maybe if I turn this camera over this way a little bit, that's probably a little bit better right there. There we go. And we can come down a little bit now. And of course, I lose the focus. Don't you love live streaming? When you're a one-man show and you don't have a cameraman behind the scenes. Ah. Okay. So we want to do a G91 with a G1E50 and F60, but I want E100. What does E50 mean? Or I mean F60. Oh, that's the rate. Okay, that's the feed rate. Okay, so G91, copy. So we're going to copy that. So we're going to go G91 and we're going to extrude 100 and go. Oh, I didn't heat up the extruder. Oh, it's going to do it on its own anyways. No, it's not. 220. Silly me. Nothing's going to happen because it's not hot enough, because it's got a minimum extrude temperature. Oh, look at that. It's going to heat up pretty quick here, though. Oops, again. Yeah, no kidding. Oops. Let's see if it still does that command when it's warm enough, or if I have to re-enter it. Here, let's watch it up here. It's not moving yet. Hard to tell if that's in focus or not. Let's see. Oh, we're at temperature. Probably have to run that again. Let me run that again and see. It doesn't want to do it. It's not recognizing the command. Okay, well, I can do it through the, we will extrusion feed rate 5 millimeters a second, and we will go 50 millimeters and we will extrude. There we go. We'll just do that twice. So all we're going to do is extrude 50 millimeters of filament twice and see what we measure. And we'll do it again. There we go. And it's at 5 millimeters a second, which is a slow rate. Okay. And now let's check our line. And we definitely extruded too much. Oops, wrong way. So we have extruded. That is going to be about 10, 15. That's about 17 millimeters. So we extruded 103. And we should have only extruded 100. And we extruded about 104. About 104 instead of 100. So we extruded 4 millimeters too much. Now let me see what it says here. Okay, we know that. calculate the distance. Rotation distance equals previous distance. Okay, so this is where I got to do some math. Rotation distance equals previous rotation distance times actual extrude distance divided by requested extrude distance. Okay, come on. Why is it making me think so hard? Okay, let's find our previous rotation distance. That's going to be in the machine. And it's going to be under the printer config. And it should be under, let's go Command F, rotation. I think it's under rotation. There we are, rotation distance right here, stepper X, stepper Y, stepper Z1, stepper Z2. There's my extruder. Is this the right spot? I think that's the right spot. Oops. Right there. Okay, current rotation distance, get rid of that, is 4.01, test for APIS, which is what we're using. Okay, 4.01. Oh, look at you, David. So we want to take initial requested, okay, rotate equals previous rotation distance, 4.01. So I want to take 4.01, clear, 4.01 times actual distance, which was actual extrude distance. Okay, previous rotation distance times actual extruder distance, which was 104. 04 equals divided by requested, and I wanted 100, equals 4.17. So we're saying it should be 4.17. Does that sound right? It's going to be a higher rotation? Yeah, I guess so, 4.17. Okay, so we go in here and we change this to 4.17. We save and restart. We'll give it a try and see. We will do that. Definitely. And we are restarted. Let's heat it back up to 220. I said 220. Oh, I got to hit tab. No, come on, 220. Why are you not? Oh, helps if I, yeah, there we go. There's that little connection issue again, but we adjusted the voltage, so we should be okay. Okay, let's go up there and mark it again. Let's go mark off 100. Oh, there we are. There's 100. There's 120. And I'll just mark it at 110 for fun. 110, 100, 110, and 120. Okay. And let's tell it to extrude 50. And 50 again. It only goes up to 50, and I don't know the actual G code to put in, but anyways. And we are, almost bang on now. I'd say we're extremely close. I'd say we're good. We're almost right to the middle of the mark above my PTFE tube here. So that worked. That fixed it. So that's good. So the E-steps are calibrated. It only gives me on here, David, unless of course that can be changed, but it gives me the options here of 1, 5, 10, 25, and 50. and then the extrusion rates of 1, 2, 5, and 10. So unless, can I manually change that? No, I can't. It doesn't let me override it. Oh, hang on. Or can I override that? It did let me override it. Let's see if it works. See if it extrudes 100. Let's try. But how often am I going to do this, right? Like, I don't really, but I'm curious. I want to see if it lets me do 100 that way. Oh, so the gears in the upper right, you're saying if I go up here, control editor, macros, miscellaneous, navigation. Filament macros. Filament macros? I didn't even know all this stuff existed. Miscellaneous, navigation, presets. Oh, look at it. I didn't even know all this existed. I got to go through this, guys. I really got to go through a lot of this stuff. Upper right. It was upper right. Right here. Here, look. Right there. Upper right. Right there. The gears. User interface settings. Yeah. Anyways, let's go through. Anyways, I just want to see, will this work? Let's just go extrude. I just want to see if this extrudes 100. I'm still getting black off of that freaking sock. And this is extruding 100. So just doing that overrode it. It worked fine. But I mean, 50 is fine for loading filaments and stuff. And it does do 100 with the load filament macro. So yeah, that extruded 100 right there. Bang on again. So no problem there. Yeah, I'm going to look through at my leisure for sure. There is some really cool stuff through here. Like, wow, especially the macro section here. That might be a real easy way to, anyways, I got to look through this stuff. This is kind of exciting stuff because it's all new to me. You're not following me again. This camera hates me. This camera really hates me. Okay, so we got our ESteps calibrated anyways. That's done. Got about another half hour to play here. What I want to try right now is I want to go into Orca Slicer. Let's connect to this thing again. I want to try one of the test prints they have, the calibration prints in Orca Slicer, like the flow rate, pressure advance, retraction test. What's the retraction test do? Start retraction length 0 millimeter, end retraction length 2 millimeter, and 0.1 millimeter steps. Hey, Dan, how are you? Man, I haven't seen you in a while. Okay, so there is a retraction. There's a retraction tower that it'll print. I want something big. I want to print something on the whole bed. But I want to design a model, like print a little garbage can or something. Good to see you too, Dan. Dollar Store Dan. Let's do this little retraction test. Although let's make it a little bigger. That's kind of tiny. Let's see if I can go ahead and under retraction test. Let's go to 4 millimeters in length every 0.1 millimeters. Calibrate more. Yeah, that's what we're going to look at and see. Oh, there, that's a better retraction tower, a little taller retraction tower. Let's see what this does. Generic PLA, let's change the color so we can actually see, because it is actually red filament. There we go. This prints a little retraction tower. Does it give me the lengths listed anywhere? I don't know. Oh, just these little notch. I see what it's doing. If you look in the control section and scroll down, you can input the extrusion values. Okay, let's look. Let's have a look. We're here to have fun. Control section. Control. Scroll down. Oh, right here. You demand. So I can go in here and put 100. Maximum is 5. Well, how often am I going to extrude 1 millimeter? Look at that. Stephen Machado, thank you. I just learned something new. Millimeters per second presets are fine. We'll keep the 100 in there. Look at that. Z offset increments. Oh, look at all that. I really need to learn all this stuff. I spend you know what? Sometimes you spend too much time building and not enough time dwelling into the actual stuff that runs the printers and helps tweak the printers, which is what I got to get into next. I mean, I love the builds. I love doing the builds. I like showing the builds, but it takes away from me getting into learning this kind of thing that you guys just showed me, especially you, Stephen, right there. I didn't know I could do that. I need to sit down, even on a stream, I don't care, one day, and go through line by line and figure out what these things do. And that way I can become a more proficient user of this equipment, right? Exactly. I mean, coming this fall, things are changing anyways. The builds are going to stop or slow down, or we'll see. But I want to get more to how to use the printers and more to what you can do with the printers. So anyways, that's my story, and I'm sticking to it. This camera hates me. It's not even giving me proper exposure anymore. What is with you? There, that's better. You love me again. The tweaking takes a long time when new to printing, of course. Software tuning, you can't really dial because change filament is such a hard. Yeah, you know what? I say this lightly, and some people are going to say no, it's not true. Anybody can build a printer. You follow instructions, you put pieces together, you wire it up based on the instructions, you build your printer, you turn it on. Hey, it works, but will it print? And it's all this sort of stuff that makes it a printer or makes it not a printer. It'll either work or it won't. And if it won't work, you need to know why. And if it works, but it works shitty, you need to know why, right? So that's kind of the stuff I want to focus on. And here's some practical printing you can do. You know, because a lot of the printers coming out today, face it, Core XY pre-built enclosed printers, right? And then you're going to have this side over here that gets those printers, and you're going to have this side over here that that likes to build the printer still. So yeah. Dan says, I'm going to start working on videos all about kinds of stuff, not just 3D. I have a video coming up on BTT Pi installing. Yeah, I mean, I just need to expand out my what I'm offering. I need to start putting actual videos on. I'm stuck. I can't quite hit that 2,000 sub mark. And I think if I start putting some videos on that people will actually watch, that may change that a little bit. So good stuff. So now if we go back here, look at that. We have 100 millimeter retract length, extrude length there. Perfect. Appreciate that tip. That was awesome. Okay, let's go back over to this. Just for the heck of it, let's go ahead and print this tower. I think my settings were fine as they were. That's going to be fine. That's like a 25 minutes. Really? Well, let's see how that first layer goes. Let's just upload and print and see what it does. Let's just upload and print. Oh, I've still got filament bleeding out the nozzle, so let's get that all out of there. Come on. I said get out of there. Get out of there. There we go. It just homed. Man, don't let your sock ever drag like that, because I'm still getting black filament out of that thing. Holy crap. I never noticed that. Okay, so for those of you that have just joined us, haha. Hey, Jerry, no problem. And hello, Jerry. No, I knew you could use it, Jerry. I don't need resin. I don't do resin, and I've got plenty of plastic. So, and you did say, hey, I'd get resin. I can always use resin, and you can always use resin. So there you go. It's my pleasure, my friend. No problem. I appreciate you. Too many printers and builds and never learn them well enough. David, exactly. I need to sit down. I should know this stuff. I really should know this stuff. But what happens is it's like, okay, RatRig's done. Get over there. Next. And I don't pay enough attention to this. And I have to start doing that. I want to learn more about the Creality system. Yeah, I know. Why? But I've got this K1. I want to learn about the Creality slicer. I want to figure this out more. Can I run this Creality printer off of Orca Slicer? Can I run this Bamboo Lab off of the Creality slicer? You know, can I drop my camera any harder? You know, all those things I want to figure out. So you're right, David. You're exactly right. You spend too much time focusing on certain things, and you're here, then you're here, then you're here, then you're here, and you're here. And you don't spend enough time here learning how to do this. And that would frustrate viewers as well. It's because, like, well, hey, you got the RatRig built. How's it printing? How come you didn't follow up on this, and this? So exactly. 3 years on your RatRigs, and look what you do with them. Man, you do some great work. So that's exactly where my train of thought is going for this channel. So perfect. I have a set of headphones that I got to print yet one of these days. I haven't had time because I've been spending too much time building. That will be an interesting video, is printing and assembling those headphones. That's a practical print. So here we go. For all of you that are just joining us, watch this beacon probe at work. Here we go. That's probably good enough view there. This beacon probe is incredible. That lighting is terrible up there. Hang on, I got to zoom out a bit here. Whoops. Zoom out. So right now we're doing our 3-point calibration. Little advice: if you want to learn more about microcontrollers, get yourself a starter kit for any controller. It will teach you how they work. Yeah, I'll show you something that I got myself, Teza, that I haven't opened in 2 years. Okay, this is just this is doing the Z tilt adjust. Now, watch how fast, for those of you that just joined, you Dan, you Jerry, watch how fast this beacon probe does a mesh leveling on this bed. And imagine if this was a BL Touch. Just look at this. She's a probing away. And it's going to do 2 passes in, I didn't time it, but I would hinder to say under 30 seconds. And here comes pass 2. I need to print a full bed print to see how accurate they are, though. Oh, I've looked at the mesh, Toph. You don't want to see my mesh. Although the mesh looks worse than it is. It's only 1/10 of a millimeter off, but it looks terrible. And here we go. Yeah, the mesh, the actual height map is awful. But at the high, it's 0.722. At the low, it's 0.5. So that's 0.2 of a millimeter off there. So there's something else going on with my bed there, but that looks worse than it is. Looks a lot worse than it is. So, okay, let's see if that adjustment on Z works. Let's see if our flow calibration worked here. This is really just a retraction test anyways right now, so not a big deal. I can turn this a little more this way. And let's put my clamp on light here, just to get a little bit more light on the print here. I need a better clamp for this light. And I didn't get a purge. Where was my purge line? Oh, there we go. Oh, I didn't do a skirt. It didn't do a skirt for me. And there's my light. That's hard for you guys to see anyways. I need to get a better camera mounted up top here. The first layer looks a whole lot better. It's got a little bit of crap all over it, but otherwise the first layer looks a whole lot better. There we go. I'm still getting gunk off that hot end from the sock being too low. Damn. And it's just the whole printer moving, guys. The new motion system changes, I like them, David. Okay, if I can zoom in here, it's actually looking not bad. And it's going to start building its two towers. And this is a retraction test, so it's going to go, obviously, we're going to check and see where we get stringing, where we don't get stringing, yada, yada, yada. Probably better off do a retraction test with PETG. It's more stringy. PLA doesn't tend to be so stringy, but hey, when the RatRig gets going, it's a force of nature. Yes, that's why it's going to be this. This is temporary. It's on a Lazy Susan. It's very wobbly. The permanent home for this sucker is, if anybody who hasn't seen, right over there. That's a really solidly built table. That is the permanent home. Up above is where I'm going to mount the spool rack, similar to this, but a lot smaller, of course. It'll be mounted up top over there, and then the RatRig lives on that table right there, so I can see it from where I am. And then that's, in comparison to the studio, there's my big screen TV I'm watching on, and there's my, all the controllers and stuff. And then, of course, we have the bench, and then we have me. So, yeah, there we go. That is where it's going. You might want it a bit lower. Actually, it's lower than you may think. Right now, this is about head level. Over there, it's going to come down to about this level here. That table is a good 4 or 5 inches lower than this bench, purposely because this is such a tall printer. And I've got to do my input shaping on this, but there's no sense at all me putting input shaping on this right now until I get it over in its permanent home, because number one, it doesn't fit on this bench. It has to have this Lazy Susan in order for it to fit on here. And input shaping, sure, it'll compensate a little bit for this, but it's going to be a whole lot more accurate if I have it on a solid surface. So 1 foot off the floor seems perfect. Yes. No kidding, right? Okay. But the fact that I got it printing, and I'm just happy we're finally printing. Here we go. There's the floor camera. There's the little retraction tower it's doing. Camera's a bit high, probably. I wonder how much lower I can get away with lowering this before it hits the rail. There we go. And can I zoom in a little further for you guys? How much further can I zoom? There, and oh, that's the wrong button. That's as far as I can zoom in. Wish I had a cameraman. I don't have a cameraman. Well worth the time adding. So far, I'm not having any issues with stringing at any of these retraction settings. There's no stringing happening at all. Again, PLA, meh. If you have good dry PLA and you're printing at a proper temperature, you really shouldn't get any stringing regardless of retraction. I guess you could eventually force some stringing with zero retraction, but I don't know. But it doesn't look like I'm going to get any stringing with this. what are the other tests that I can do on this? So they have the calibration. So we have a temperature tower. We don't need to do a temperature tower right now. How about flow rate, pressure advance, retraction, pressure advance? I don't know. I don't have a lot of time left for this stream, so I want to print a big. I do want to, we're going to tune this more, but I also want to. Test the whole bed, just to make sure. Let's see if I can find a big print. Massive stringing with PLA, but then not air conditioned over 50 to 90% humidity. Oh, what I want to try after this, let's run this. I think what I want to try after this, I want to get that that part cooling fan working properly. So I think we're going to go back to who said it. I think we're going to go back and see about connecting, but I was going to be cautious about this because do I need to remove a pin? I never understood. You guys can confirm this for me, those of you that know more than me. So if we're looking at this, okay, so what was recommended was that on my fan, I don't have a separate PWM wire. I have a black and a red coming out of my fan, period. Okay. Now it was suggested to me that I take the red and I plug it in where the PWM pin is plugging in. That's what I guess. I mean, I'm not going to hurt anything because if worst case, that's a ground. But that should also be a signal pin for the fans. Is that right? That might be. We'll try that. What's it going to hurt? What's it going to hurt other than my ego? Because yeah, right now the part cooling fan is on constantly. So you may have the fan in the wrong plug or the pin mapping wrong. You think so? We'll look at that in a second. Well, this is printing. Okay, well, this is printing then. Let's just have a look. Let's go ahead and look for the assembly, RatRig V-Core 3.1 assembly. And it was in there that I found the pin out. I believe it was electronics. There's our board. So now let's see. Part cooling fan. Oh, maybe. Hang on a minute here. Which board? Big Tree Attack Octopus. You know what? You might be right, David. Okay, part cooling fan. Yeah, you know what? I think I have it in the wrong spot. I have it over here. And it should be here, which is probably the signal pin right there where it's telling to put the PWM. I might have been looking at the wrong diagram. Yeah. Well, there's my 80XL. This is a good screen to keep open. Okay, you may be right, David. I think I have it in the wrong spot. Oh, we're getting some stringing now. Good. There's a tiny, 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 I doubt you'll even be able to see it. No, you won't be able to see it. There's a tiny, tiny bit of stringing. Maybe red wasn't such a good color. That would scotch the control. That would scotch the control. You really don't like me, do you, camera? No, you don't. There you go. Okay, let's let this thing finish. How much longer do we have on this? Okay, now we're getting some good stringing because I think we're down to close to 0 retraction. Yeah, let's see. Okay. Yeah, I think I have it in the wrong spot. I really do think I have it in the wrong spot. Okay, well, before I run out of time, let's go ahead. We know this is working. Where is Orca slicer? There we go. And device. And it says we have how long? ETA 18 minutes? No, it's not that long. Let's stop this test. I really want to get that fan working. There we go. Okay. And let's wipe it. So let's go here and let's look. So according to the electronics wiring for the V-Core 3.1 Octopus V11 wiring diagram, the part cooling fan should be plugged in right there, right next to the electronics, right next to the hot wiring area. Power down. Power down. Yes, let's power down. And actually, let's let the hot end cool off a little bit first so we don't get any heat creep up it. And let's pull this off of here. There we go. Yeah, see, this is I'm still getting, look at the black crap from my sock when my sock was sagging. I got a lot of filament, I think, stuck up under that sock. I'm gonna have to pull that sock off and clean up under there. So that how much red have I put through there now? And I should not be getting black leakage like that through there, but hey, otherwise it's a nice clean print. So, and it's, yeah, definitely doing good other than that. But yeah, let's get this fan working, because without the fan working properly on the first layers, it's just it's not worth continuing on. I just want to let that hot end cool off a little bit. We've got about another 10, 15 minutes. Mama's gone out to a movie, so I'm being solo dad tonight. Ethan's upstairs being really, really good. Mama went out to see Sound of Freedom. I saw it last night. She went with her mom to see it today. So awesome. So let's let this cool down. So good progress. Man, I'm excited to get this thing running now. I want to print a garbage can for down here. But I want to put a, that's a fragment, not a contaminated hot end. Yeah, but the fragments are, I'm getting but it's because I had that stupid sock down, and I think what's happened is there was stuff all built up. I don't know where it's coming from, but I want to pop the sock off and see. Maybe we'll do that after this cools down a bit too. So I know that I want to let it cool down a little bit. I've had an issue in a Voron with before where I would turn the power off without the hot end cooling down, and we got heat creep going up, and it actually melted the bolts through the plastic because the heat creeped up. So I learned my lesson that way. That movie, a lot of theaters are avoiding it, which is a shame. It's a good movie. It's a great movie. You could look but not touch. Lower the bed before powering off. Yeah, good idea. Very good idea. We got to home it before we lower it. So let's home it while we're doing it. I always, thanks, Toph. I'm guilty of that. I turn it off and go, shoot, I should have lowered the bed. Just knocked a pin. Oh, it's a little wire. That's okay. One of my wire retainers came off. I didn't like it anyways. Okay, let's lower the bed, and actually we'll bring the hot end up to the front too. Actually, let's not. Let's lower a little more than that. Let's lower it a couple hundred. There we go. Done at 100. Yeah, I know. Don't you hate that? And then you go, crap. You can either do the screws manually or you can power it back on, which is the way to do it. Okay, that's how we'll just go down another 50. And we'll bring the hot end towards me a little bit. There we go. Okay, good. Okay, we should be cooled down enough. Yeah, 66 degrees. We can power it off. So let's go ahead and their way, and we go shut down. Come on. And shut down. Okay, so we're shut down. Let's grab my light off of here so I don't knock it off. Still, I've had this thing on for about 3 hours now, and it's still, between last night and tonight, it's still 50% battery. Okay, we'll turn this around, power this off. Let's just undo the power plug here so it doesn't get in the way. And let's see where my fan's at back here. Oops. What am I hitting? Well, I'm hitting my spool up top here. There we go. Okay. Okay, let's grab this camera here. And let's just see where I am plugged in. Oh, none of my fans are plugged in where they say to, but that's okay. Oh no, I don't have a control board fan. That's fine. So this fan here is my hot end fan. Yeah, okay. So it's definitely not. Here, if I can zoom in with this one, let's just see how far in I can zoom. And it went dark. Okay, that kind of gives you no, yeah, okay. So if we look at the actual instructions here, and I don't know what I was looking at before, but right there's the park cooling fan, has it plugged right in beside these, and right beside the park cooling fan is the hot end fan. And then we have a controller fan. I don't have a controller fan on here, so that's fine. So we should have park cooling fan and hot end fan, and we want to make sure the park cooling fan is, what voltages do I have that set at right now anyways? That's 24 volt, the park cooling fan, as is the hot end fan. So our jumper's in the right spot. So right now, I have the park cooling fan plugged in over here, and it should be plugged in over here, instead of over here. So yeah. So let's go ahead and see if that's going to make a difference. So let's go ahead and pull out the park cooling fan. Let's make sure that is the park cooling fan. It is PCF from here. And then we will switch it over to here, and our jumper is in the right spot. They're all set at 24 volts because they are 24 volt fans. And that should go in right there. That should fix my issues. We hope. Let's see. Okay. Let's see if that does it. So we'll turn it back around. We'll plug it back in. And I should be able to tell right away when I turn it on. No fans come on. That's good. Good. What? See, this camera hates me. Why do you keep, stop. Don't be, why do you keep, am I that ugly? What are you doing? What's going on with this thing? Okay, we'll just switch to this one. Dang. So powered on and there's no fans on. That's a good sign. Now we'll launch mainsail. As soon as this thing launches. Okay. And let's launch mainsail. Okay, we are launched. Now, on mainsail, all my fans are off. Controller fan, I don't have 0, 0. Let's see. Okay, we're going to slide that on. We're going to come over here and we're going to turn the fan on. And we have park cooling fan 100%. Turn the fan off. Park cooling fan off. That was my bad. I'm not ugly. You're very retractive. Andrew. Okay, park cooling fan fixed. That's that. Tell you how much I love this light. This is a great little light. Blair Witch Project. Anybody seen it? I'm sorry. Anyways, I think we've had a good run of it tonight, guys. We got a print. Well, we printed partial. Oh, I want to check under the sock. I want to check under the sock. Yeah. So let's go ahead. I'm going to bring this other camera. Let's bring this camera down a little lower so you guys can check under the sock with me. We're going to pull our socks off. Yeah, that's down, and this one's down. I need to find a really decent camera mount that I can mount on the ceiling that I can actually just take and boom, 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 boom. There's the camera angle. Boom, boom. There's the camera angle. I guess I could 3D print something. That's one of the things that I want to do is more projects like that. So let's see if I can get you guys zoomed in on the sock. Well, that's kind of way out of whack. Where are we? Oh, there it is, right there. Okay. So let's zoom it out a little bit. There we go. I just want to see what the heck, why there's so much gunk coming out of it. Yeah, we're cooled off good. Can I even get the sock off? Oh, come on. Oh, there's gunk buildup all over the side of the nozzle, so that's probably not helping. What I really should do is put that, let me see if I can get a little hand here. I have some stuff that you paint on the nozzle so plastic won't stick to it. I should try that. Huh. You need a roof-mounted rotating cantilever camera mount. Exactly. The sock should come off a little easier. I don't want to damage it. Maybe I should just leave it for now. Huh. Almost like it's melted on there. You're just tinker-cadding and watching Tim. Ah, okay, Dan. I'm struggling with my socks. Let's move it over a little bit. See if maybe. Man, that should not be that hard to get off. There we go. Now it's coming. Now it's coming. There we go. Okay. There's a little bit of filament buildup underneath it. That's probably why from when I had it dragging. Yeah. Yeah, otherwise it looks okay. There's no major buildup of filament in there. There's a little bit on the back here. Yeah, little tiny bit. Yeah, I had a few pieces fall out, but I think that's what happened when I had the sock dragging. It was killing my first layer. I didn't even notice it was dragging because I was too focused on everything else. There we go. There we go. The nozzle is heat tightened. Well, according to what I read on this hot end, you don't have to heat tighten this nozzle. So no, it's not, but I should. According to what I read and what I was informed is that it doesn't need heat tightening, but here we go. It's got some really pretty red paint under it. Yes, careful with those cutters, I know, especially around this kind of a heat cartridge. So yeah, we'll heat tighten that. We can heat tighten that. And then I'm also going to put some of that, I don't remember what it is, but let's go ahead and heat it up since we're here and we're watching. And I've got another, oh, I'm a little over time now, but that's okay. Let's go to 250. Let's heat the nozzle up. And we'll snug it up a little bit. I don't think that's the issue, but yeah. And that should be an 8mm, 8 or 7mm. No, it's going to be 7mm. Seven millimeter. 7mm wrench. It does look a little yucky. There we go. We're tightened. I'm probably going to have to adjust my Z a little bit. Oh man, the wrench gets hot. Oh, there's a little bit. Let me grab my brush. Yeah, there's a little bit of seepage. Maybe that was not nearly tight enough. Let me be very careful with this. There we go. That looks better. That looks better. Okay, good. Yeah, I think we had a little bit of a leakage happening. Yeah. Yeah, it moved too easy. Yeah. Okay, good. I'll just have to recalibrate Z, which is no problem because that actually moved a fair bit. See, I'm focusing on too many other things and not paying attention to the little things that matter. I'm so guilty. I'm so guilty. But I'm over it now. I know. I should just leave this up to the professionals. Jeez. Give the guy a YouTube channel. He thinks he knows what he's doing. Okay. Yeah, we're much better now. I wonder, let me cool that off. Oh, it's already heated and tightened it. Already heated and tightened, cleaned off. Got to be careful with the wire brush, especially on this. You don't want to get it up near the probes. You don't want to short anything on the hot end. You don't want to get it near the beacon probe, which is right there. You can just see right here. That's the beacon probe right there. So, yep, it's looks like it's a whole lot better. We're better, we're tighter. Now let's see if I can't push on the let's make sure I get this right. Put the sock back on. There we go. Oh, that's freaking hot. And the sock is back on. There we go. We are good. What'd you miss? Been with the police, you just got back. Nothing. You missed the fact that, man, whoever put this freaking hot end together, they didn't tighten it properly. They didn't hot tighten the hot end because, you know, they were so busy doing other stuff. And I mistook it. I mistook it. It's the Revos you don't have to hot tighten. It's the Revos, and this is not a Revo. There we go. So now we fixed that. We cleaned it up, and hopefully that got rid of all the black gunk that was in there. Okay, let's get this camera. Man, that's terrible, that little guy there. What's going on with you? What's your problem, camera? Yeah, Jack, is everything okay? Did they arrest you? Throw down in the parking lot. Wow. I hope you're okay. Did they hurt you when they threw you down? No, not you. Good, good. Yeah, sure. We're going to see you in the local news or something one day. Okay, well, I think that's enough for tonight. We've had lots done. I think what I'll do, yeah, I did. I checked, Teza, I did look inside the sock before I put it back on. It was clean. I mean, I could probably pull it off a lot easier now because it's not so much mess in there, but that's a little bit warm right now still. But I want to paint my nozzle with that plastic repellent. Yeah, there's my sock. Actually, you can probably, yeah, the inside of that sock is clean. Yeah, that wire brush right down to the tip. Yeah. Is that cooled off a bit yet? Oh, it's still a bit warm. I shouldn't have to paint it because I have the sock on. Although I could paint the tip of it. Let's see if I can find that stuff. Let's see. I don't know where I put anything. That's the problem. Where would a guy put plastic repellent? I have 4 bottles of it. I gave one away. Huh. Oh, I think I know. Maybe not. There it is. No, is that it? No, that's goop. That's 3D gloop. No. Anyways, I'll have to find it later. I'll leave this off until I find it, and I'm just going to put some little plastic repellent around the tip of the nozzle. Might help it a little. Okay, this camera really does not like me, does it? Do you? Stubborn little thing. Did you make it in time for pizza? No, you didn't. Okay, well, we're after our time. Listen, everybody, thank you. David, thank you. Teza, thank you. Jack, everybody who's here. Did you make it in Happy Manufacturing? I'm just about to wrap it up. I'm sorry, man. Yeah, follow me, camera. Like, I've got to figure out, it's something to do with my settings on this. The thing is, when you have face detection on this camera, yeah, when you have face detection on this one camera, there it is. It's working now. There we go. What happens is if it loses your face, it's got a resetting thing it's got to do. So, no, thank you everybody for being here. If you guys weren't here, I wouldn't be streaming, and I'm glad we got this done. But I think what I'll do as a finale for the RatRig, because it is running, it's printing now, I think, and we're going to do some tuning through the week. But I think what I'd like to do is next Sunday, I'm going to design myself. I say design. I'm gonna make a large garbage can. So probably about a 300 millimeter base and have it taper up to about 450 millimeters, and we'll make it yay tall. But I've got to find, and I don't know if, I think this is just a standard V6 nozzle this takes, but I want a 1 millimeter nozzle for it. So what's going on here? There we go. And I want to get a 1 millimeter nozzle to do it and do it in vase mode. So we made some progress. We did for sure. Where's the print? Well, the print we did the other day, where did I put it? Is we did get a print out of it. We printed a little temperature, a little retraction tower. We printed this print yesterday. We printed a little retraction tower today, but then we just got into doing some adjustments and so forth. So, but we will do, yeah. You may want to think about a filament out sensor, possibly. I have a love-hate relationship with filament out sensors. So, but I do have a sensor sitting here somewhere that I could put on it. It's a good one too. So anyways, guys, next week we'll print a garbage can. Why not? And then we'll talk about what's going on going forward. So 1 millimeter nozzle for sure. 1.2 vase mode, and it should be okay. Yeah, and I want to do a nice strong garbage can to get rid of the cardboard box I have down here. So why not? So, hey guys, thank you so much. I appreciate everybody being here as always. And we'll catch you guys next week and through the week. And thank you guys. Have a wonderful night. Everybody take care. I love y'all like you were family, and because you are family. So you guys take care. Bye for now. Have a good week.